the loads in the home, and then I think it just kept on tripping out. So the system was not working properly for some reason. And the electrician told my client that he believes the 20 kVA AVR is not big enough. So therefore, the client should put that in the bin, if you like. Hi guys, welcome to AsherGad channel, making Africa home again, one family at a time. Thanks for joining us once again on Tuesday, 6 p.m. GMT. Trust you guys are all doing well wherever you are on the four corners of this earth, making gradual plans to make your dreams become a reality on the continent. All right, so today's video is another brief one, and today I just want to bring an experience to you that we had recently with AsherGad consultancy. I want to show you an example of poor electrical wiring, poor electrical installation, really fundamental errors, what we were called in to do, and then how we've now resolved the issue and everything is working perfectly. So let's go straight into it without any further ado. Okay, so client called me, I think it was about 2 weeks ago now, and basically the client has got his electrician to install an AVR, a three-phase AVR in Vensis, a 20 kVA, and for some reason the system was not working properly. I think I can't remember the exact details, but I think they put on the loads in the home, and then I think it just kept on tripping out. So the system was not working properly for some reason, and the electrician told my client that he believes the 20 kVA AVR is not big enough. So therefore, the client should put that in the bin, if you like, and buy a new 35 kVA AVR, and that should solve the problem. Mind you, a 35 kVA three-phase AVR is about 21,000 Ghana cedis, price in dollars on your screen. Okay, so the client was obviously a little bit concerned, and what he wanted was a more professional look at his system from a designer's perspective, somebody who understands the theory and the practice. So he gave us a call, explained the situation to him, and we were like, okay, you know what, don't replace the AVR yet, because this problem may not be from the AVR. Let us inspect the entire installation from the beginning to the end, and let's see what the situation is. We did that and made quite a number of corrections. There were quite a few fundamental errors here, and now the system is working perfectly. But before we get into the solution, let me first show you some pictures of the existing installation, and you can see that there are some errors here. So the pictures will be coming up on your screen. Now, but bear in mind, this is a huge house. This is a 5-bedroom house. So the first thing that I saw when I went there was they've got the a 16mm cable coming in from ECG. Okay, that's genuine. That's okay. That can take about 80 amps, so that's fine. That comes into the 100 amp breaker supplied by ECG, which then goes into the meter, and then from the meter they have a changeover. The idea of that changeover is so that they can have a backup generation that can support the house, as well as when ECG is not available. Now, the issue with that is, on your screen again, is that the electrician had installed a 63 amp manual changeover for a 5-bedroom house. Far too small. It needed to be 100 amp, just the same as the ECG 100 amp breaker for the supply coming in. I mean, why would you reduce it? That's the first thing that was wrong with it. Then from the changeover, I then went into this client's electrical room to have a further look at the installation. So the client has very smartly got his electrician to put in a surge protective device, SPD, again, picture on your screen. But for some strange reason, the electrician had only wired 2 phases and then to earth. Well, what's going on here? When you look at the manufacturer's detail wiring diagram on the side, it clearly tells you wire in all the 3 phases and the neutral, and then wire in the earth connection. The wiring details are on the side. That's the instruction from the manual. So why do something different? Another error. Following on from that, for some reason, the electrician has installed another breaker to feed the AVR. Not sure why, but that's fine. And that other breaker was again a 63 amp breaker. Okay, so again, not the right size for the house. Needed to be a 100 amp breaker. So again, we got him to change that. Okay. Also, there's a junction box coming on your screen. This is very dangerous. He had a number of cables. There's some cables that are coming in from the changeover, fairly sizable cables. I think 16mm cables, and he's joined them into this sort of connector, but he's looped them with a smaller cable. Whoa, why? Why would you join a smaller cable to a larger cable when you are supposed to be sort of conducting the same amount of current? That is wrong. The cables in that junction box should all be the same size. Error. Massive error. Dangerous as well, because that could cause a fire. Another thing we spotted, the AVR itself is a 3-phase AVR. Okay? A 3-phase AVR. Okay? But for some reason, the electrician had only wired 2 of the phases. Not sure why. Why would he only wire 2 of the phases? Absolutely doesn't make sense whatsoever. Okay, so now that is the reason why the actual AVR display itself was only showing phase 1 significantly as a value and a little bit on phase 3, but phase 2 didn't have anything on it, as in the B phase only had 0.1. That's because simply the AVR was not wired. Very simple issue there. The AVR chassis was not connected to earth, and that's a safety issue. And if you haven't watched my video on earthing, click up here and you can watch it. Anything that is metallic, that has electrical wires within it, the metallical body of that item needs to be connected to earth. That is a safety function, and it's absolutely necessary. Because the reason why it's necessary is the metal surrounding the electrical item can become live if there's some electrical fault within it. It can become live, and you don't want to have an electric shock by touching it accidentally. If it's connected to earth, then the fault current will travel to earth, and then you will be fine. Okay. Now, the distribution board incomer, the existing distribution board incomer, also for some reason only had 2 out of the 3 phases wired. Again, madness. I don't get it. Why do you have a 3-phase distribution board and only wire two of the phases? Something is wrong here. The system will be unbalanced. You need to balance the loads across all 3 phases. Another cowboy thing, very dangerous thing, is that the earth cable. Now, earth cables are always the green and yellow cables. Okay, these are standard, industry standard green yellow. When you turn up to a distribution board and electrical installation, wherever it, and you see a green yellow cable, you know, that's my earth cable. But for some reason, this electrician, he had used the earth cable to wire as a live conductor, as one of the phases. Why? Why would you ever do that? And when I asked him, he said, oh, because they were short of cables. Well, no, that's not good enough. Keep the color codes correct, because if somebody comes later on, it may not be this electrician and another electrician, and so they look at it, oh, this is earth, and then they touch it by mistake or do something, or wire it by mistake. That's where you could have significant problems, an explosion, a short circuit. Somebody could have a fatal injury. What have you? Keep it correct as industry standard. Very, very dangerous. I condemn that straight away. Okay. Another issue was that again, this is, I guess, one main issue here, is that this electrician that I met was the 4th electrician on this building. Okay, they've been changing electricians over the years for whatever reason, so it's not entirely his fault, to be fair to him. Now, the distribution board that was installed for this house was too small, far too small. They installed an 8-way 3-phase distribution board, and all the breakers are completely full up, to the extent that they had to now sort of come off the supply cable to put a branch connector to connect 5 AC units. So 5 AC units are not going via the distribution board. There's a connector on the side. I think I got a picture. It's on your screen if I do. There's a connector on the side of the distribution board where they've sort of connected in the 5 AC units and sort of jumped off the incoming cable, which again, electrically, that works. It works in the house, but it's very, very dangerous. Bad practice, poor practice. You've connected the small AC circuits, the small AC cables onto this connector without any circuit breakers. And that is a fire risk. That is a fire risk. You know, the electrician knows how to wire stuff, but he doesn't understand the theory. Maybe he's come up through the apprentices route, so therefore he does not understand the theory. A consultant was not employed to look at this installation. So again, 100% wrong, and I just condemned it straight away. Okay, and told the client that first of all, we need to fix all these problems. The distribution board is also not labeled. Okay, that needs to be labeled. We need to fix all these problems, fix all the problems. Let's come back and do a test, which we did. And if the test, putting all the air conditioning on, lighting on, if after the test there's still issues, then perhaps we can change the AVR. But for now, let's correct all these issues, do a test, and then we will see if it passes or fails. Then we'll know what to do with the AVR. Okay, but before I tell you guys what actually happened with the test and the end result, let's just go for a break, and we'll see you right after the break. Are you looking to build your dream home in Ghana? Or are you building already? Would you benefit from regular site visits to monitor your building and receive regular progress reports? Well, if that's the case, and that's you, look no further. AsherGad Consultancy at your service. We offer the following services: electrical design, construction monitoring inspections, site progress reports, consultation for all items MEP, witnessing of testing and commissioning, periodic snagging, vetting of specialist subcontractors. We also report site activities to you to hopefully help you spend your money efficiently, and much, much more. Get in contact for your building needs. Details on the screen. AsherGad Consultancy, making Africa home again, one family at a time. Hi guys, welcome back. So you know, after all these corrections were made, AsherGad re-attended site again to inspect what the electrician had done. The electrician had installed and made the corrections as we advised. He had also, you know, recommended some. He also changed some other devices in the installation, which we didn't recommend, which wasn't necessary. But anyway, he did it anyway. Not sure why, but anyway, everything was done. The 63 amp changeover was changed to 100 amp. The SPD was wired with all 4 phases. The Havel's breaker was changed from 63 to 100. All the small cables were changed to the right size as the other incoming cables, all 16 mil. The AVR was the 3-phase AVR. Guess what, guys? Was wired as 3-phase, as it should be. All right. You know, the AVR, the metallic chassis of the AVR was connected to earth now, so that was all nice and safe. We then proceeded to turn on the system, and guess what? The AVR display was reading all phases, A, B, C, L1, L2, L3. Then what I got them to do was to turn on all the loads in the house, turn on all the lighting in the house, turn on all the 9-number air conditioning units, turn on the water pumps, open the taps so that the automatic pumps are working. I just wanted to test the system in madness to see what the maximum load would be at that point in time. Obviously, this is a house with no kitchen appliances, no fridge, no freezer, no cooker, no electric cooker, nothing. So I was just using the loads that were available to me to see, to put the system to a test. It's, in electric terms, we call it a soak test. So put it to a test, and it passed with flying colors. I'm showing the picture on your screen. We had not all the loads in the house, but most of the loads in the house on, and we were registering the highest amount of current we were registering was about 21 amps. You can see that on line 1. The first one, 21.4 amps. The second line, which was not used at all previously, was now registering about 18.4 amps. So it is working. When I turned that previously, they said, oh, there's something wrong with that second phase, it's not working. No, there's nothing wrong with it. It's the way you wired it. Okay, it's a machine. If you wire it correctly, it will behave correctly, as long as obviously there's nothing damaged within it. So second phase, 18.4 amps. Third phase, around 20 amps. So all 3 phases were fairly balanced. Fairly balanced. We're all within, generally, a plus or minus 10% difference. And that is fairly good. All were fairly balanced and working perfectly. We kept all the loads, the water pump, the AC. We kept everything going for about 10 to 15 minutes just to make sure that we weren't going to find any hiccups later on. And it was fine. It was perfect. So rang up the client. He was very, very happy that he engaged our professional services. And then, I'm happy that, we have another satisfied customer who decided to reach out and to get his problem solved rather than taking the electrician's initial word for it. Because what would have happened then is the remedial works that we recommended costed about 15,000 Ghana cedis. If he didn't go down that route and he went to spend 21,000 Ghana cedis on a new 35 kVA AVR, he would have bought that, installed the AVR, and the problem would still be there. So that would have meant he would have spent 21,000 cedis on a 35 kVA AVR plus another 15,000 cedis to correct the other fundamental electrical problems that are there now. That were there, sorry, which would have been a waste of money. It would have been a waste of 21,000 cedis. Okay, so it's important. That's why I said never underestimate the importance of building services designers. I did a video on that, the importance of building services designers, and if you haven't watched that, guys, please click up here. The importance of building services designers. Please click up here and watch it. You see, engineering is not copy and paste. Every house is unique. So therefore, make sure that your system has been wired uniquely to suit your brief and also correct to the right standards and regulations that are safe, and making sure that your house won't experience any faults. Okay, now in terms of the distribution board, there was an option to keep the existing 8-way distribution board and put a small 6-way single-phase distribution board next to it to feed the air conditioning circuits. Now that would have been fine, but having spoken to the client and having liaised with him, he was happy to spend the money to replace the existing distribution board altogether, put it aside, and just put in a brand new 12-way 3-phase eating distribution board so that all the circuits could just be in one place, nice and neat, job done. Okay, and that was it. So that 12-way 3-phase distribution board was 2,800 Ghana cedis, including the incomer. And that's the images you've seen on your screen, and it's all working perfectly now, which is great. I have some really good suppliers when it comes to electrical items or products now. So if you are buying your electrical items, by all means get in touch, and I can happily recommend you some good guys out there who are supplying quality products, be it distribution boards or automatic voltage regulators, which are very important. Or if you're going to have a 110 and a 220 system, obviously you need the 110 transformer. So I have guys who are supplying that quality products, which not only transform the voltage but also the frequency, etc., etc. So it's all available to you. It's all available to you guys for those who are interested and those who need it. This client has also requested that I do a drawing for him. So there's a drawing going out to this client which he will stick on the wall, and I recommend this also. Have an electrical schematic on your wall that shows any electrician who turns up to your house how the system is wired. How is the generator cable connected? How are the breakers connected? How is the ECG cable connected? How is the AVR connected? The 110 transformer, the changeovers, so that any electrician who comes there can simply look at that diagram and know exactly how your system works and know how to fix any issues that you may or may not have in the future. Very important. Most electricians do not do that, but we always recommend that you have an electrical arrangement schematic on the wall in your electrical room. It's a manual for the future. All right, guys. Well, I hope you enjoyed that. As usual, like, share, subscribe, hit on the notification button so you always be aware when AsherGad upload a new video for your viewing and educational pleasure. All right, so from God, it's Chemist here, and for me, guys, Yebeshia. See you next time.